everyone, welcome to today's exciting demo video. We are thrilled to showcase a proof of concept that demonstrates the incredible capabilities of AI in generating image variations. This app uses the power of open source models, specifically the Stable Diffusion Variation Pipeline from Hugging Face. By using these advanced and freely available models, we can create high quality image variations that are perfect for creative projects, content generation, and much more. So let's dive right in. But before we start with the discussion, let's just quickly take a look at what we will cover in this video. So our first topic would be the image variation model itself. Here we will have a brief introduction to the model and we will also check out its model card on Hugging Face website. Then we will discuss the use cases for this model, following which we will have a demo and code overview. And after that, before closing, we will discuss the advantages and limitations of using this open source model. So let's start with the first topic, which is image variation model. The backbone of our app is the Stable Diffusion Image Variation Pipeline from Hugging Face. This model is designed to generate high quality image variations, making it perfect for creative projects, content generation, and much more. It uses deep learning techniques to provide visually appealing and unique variations of input images. This model focuses on creating new content from existing data. Let's try to understand how it works. So, the model uses a form of deep learning called diffusion models, which iteratively refines a noisy image until it becomes a clear, coherent image variation. This process mimics the way an artist might refine a rough sketch into a detailed artwork. The model is trained on diverse dataset of images, learning to understand and recreate various styles, patterns, and details. This extensive training allows it to produce visually appealing and unique variations that stay true to the original image's essence while introducing creative elements. One of the key features of this pipeline is the guidance scale parameter, which controls the creativity of the generated images. A higher guidance scale leads to more diverse and imaginative variations, while a lower scale produces images closer to the original input. This flexibility allows users to tailor the output to their specific needs, whether they want a subtle change or dramatic transformations. Now let us take a look at the model card for this model on Hugging Face website. So this is the web page for this model on the Hugging Face website, and this here is the model card for it. In here you will find comprehensive details about the Stable Diffusion Image Variation Pipeline, including its capabilities, training procedure, uses, and limitations. So let's just check this out. So here they have given a brief introduction to the model. They have mentioned that this particular model, that is the version 2 of Stable Diffusion, has been fine-tuned from the original version, and that this particular model was trained in 2 stages and longer than the original model. Then we have the example usage of this model. Here they have shown how we can use Stable Diffusion Image Variation Pipeline to access the model and use it by means of this code snippet. And here they have also emphasized the importance of resizing the image correctly before passing it through the pipeline so that the images are transformed properly. So this is something that needs to be taken care of at the time here when we are passing the input to the model. So this needs to be kept in mind while using this model. Then here we have the comparison between the outputs of the version 2 and version 1 of this model. So this initial section of images, here you can see that the first image in here is the original image and the following images are the variations that have been generated using the version 2 of this model. And then in this section we have the images that have been generated using version 1. So here you can see and compare the difference in the results of these 2 versions of the model, and clearly we can see that the second model is more detailed and giving much better variations in the image as compared to the first one. And they have also mentioned it here as well, and this is because the second model was trained longer than the first model, because of which the model has memorized some common images from the training data. So this is what is helping the second version of the model to generate better output. Then they have also detailed on the training procedure that was used. As discussed already, this particular version of the model was trained in two stages, stage 1 and stage 2, and they have given the parameters and the technical details for these two, along with the hardware that was utilized and the optimizer that was used as well. Then they have listed how this particular model can be used and how it should not be used as well. So here they have also mentioned that we are not to misuse this model to create any kind of malicious content, and what would be consisting of the malicious content that has been listed down here. Then we move on to the next section, which is the limitations and bias of the model. In this section they have listed the limitations of the model and its biases. Some of the limitations of the model is that it cannot achieve perfect photorealism, it cannot render legible text, and like faces and people in general may not be generated properly, and that this model was trained mainly with English captions and will not work as well in other languages. So you can check out this model card to get more information on this model. Then here we see how many times it was downloaded last month, and we also have an inference API here where we can use this app in real time. And this can be done when you are logged in, so you need to log in to use this feature. So I'll just pass in one image in here. I'm not passing any prompt, and you can see this is the variation in this image. Now let's just try one more image. So I'll pass in this one, and you see it gave a variation for this image as well. So this is how this model functions. Now let's move to the next topic, where we will be discussing the use cases and who can benefit from them. So this app can be useful for various users. If you are a student, then you can use it for educational projects. Students can use this app to create unique image variations for their school or university projects, helping them stand out with visually appealing content. They can also use it to learn AI concepts. By experimenting with the app, students can gain a deeper understanding of AI and image processing concepts, bridging the gap between theory and practical application. They can also use it in creative assignments, where art and design students can use this app to generate inspiration for their creative assignments, exploring different styles and variations effortlessly. If you are a developer, then you can use it for prototyping new features. Developers can use the app to quickly prototype new features in their applications, testing different image variation functionalities without extensive development time. They can also use it for integrating AI capabilities. The app provides ready-to-use solution for integrating advanced AI capabilities into existing projects, enhancing functionality with minimal effort. Developers can also use it for open source contribution. Developers who are interested in contributing to open source projects can use this app as a starting point, experimenting with the model and potentially improving it. For businesses, it can be used for marketing campaigns. Businesses can use the app to generate diverse and engaging content for their marketing campaigns, creating visually appealing images that capture attention. They can also use it for product visualization. E-commerce companies can use the app to create different visualizations of their products, helping customers see various styles and options effortlessly. They can also use it for branding and design. Branding teams can use the app to explore different design variations, helping to develop unique visual identities and stay ahead of design trends. Now that we know the use cases, now that we are familiar with the use cases for a variety of users, we are in a position to move to the next topic, which is the demo. Here we will see the image variation generator in action, and we will also briefly discuss its code. So before moving to the demo, let's just quickly take a look at the code behind this app. We'll break it down step by step to understand how each component works together to create image variations. So first of all, we'll be setting up the environment, and we need to install the necessary libraries. We'll be using the diffusers, accelerate, safe tensors, transformers, control net orgs and media pipe libraries along with grade.io. So that is why we first need to install them. In the first two cells, this one, and here we have installed the libraries. We have already run the cells. Then the next step is to import these libraries. So these libraries provide the tools we need for loading and processing models, handling image transformations, and creating a user-friendly web interface. And the imports in these two cells, cell 3 and cell 4, include utilities for image loading and transformation, model loading, and creating the grid IO interface. You can see here in cell number 4, in the last line, we have imported the grid IO library, which is going to be used for creating a very basic interface for the app. Then the next step would be loading the model. We initialize the device and load the Stable Diffusion Image Variation pipeline from Hugging Face in this cell. In the first line of this cell, device equal to CUDA 0 specifies that we are using the first GPU for computation. The model is loaded using the from pre-trained method and moved to the specified device. And then we come to the function which is the heart of this app, which is called process image. So in this function, the input image is transformed into a tensor first. It can be seen from this line. And then it is resized to 24 cross 24 pixels, which can be seen from this line. And then the image is normalized using predefined mean and standard deviation values, which can be seen here. So the transformed image is then passed through the model. Here, this input is being passed to the model with a guidance scale of, and then in this input variable, we have the transformed image with all the transformations that have been applied to it. Once we are ready with the input image, then it is passed to the model with a guidance scale of 3. It can be seen from this line. So this guidance scale parameter controls the creativity of the output, and then the model returns a set of images and we select the first one as the output. So you can see here. So this out variable consists of the multiple images that are being generated by the pipeline, and then we choose the first one out of those. And this code here is corresponding to the interface that we have created using grid IO. And this is our interface. So you can see how easy it is. It's just this particular function in here which involves some level of coding. So using open source models to integrate into your own system is very easy. Then we move on to the interface. This is our basic interface. This section would display our input image, and here we'll be provided with the output image. So let's just again select that same image and I'll submit it. You can also see the time the model is taking to process it. So it took approximately 24 seconds to process the output. And you can see here, this is the output. This is another variation of the same image. We passed it again and we can see this is another variation. So this is how this app can be used to generate variation of images. And this was our demo. Now we'll move to the next topic, where we will be discussing the advantages and disadvantages of using this Stable Diffusion model. So in the following section, we will be discussing the advantages and limitations of using the version 2 of the Stable Diffusion model, which is being used for image variation. So we will start with the advantages first. The first advantage is cost effectiveness. Using open source models eliminates the need for expensive software, reducing costs significantly. And the second advantage is community support for this model. So we can benefit from a vibrant community of developers and researchers who contribute to the continuous improvement and provide supports to this particular model. Next, we have transparency. Open source models offer transparency, allowing users to understand the inner workings and make modifications as needed. Next, we have versatility. Users have the flexibility to customize and extend the model to suit their specific needs, ensuring it aligns perfectly with their project. And the next advantage is rapid innovation. Open source projects often benefit from rapid innovation with frequent updates and new features driven by community contributions. We now move to the limitations, and the first limitation is complexity. Implementing open source models can be complex, requiring a certain level of expertise and technical knowledge. Because if you are a beginner, then understanding the code and concept can be difficult. The next limitation is limited support. Unlike proprietary solutions, open source models may not offer dedicated support, leading to potential challenges in troubleshooting. Currently, we have an active community support for this model, but this may change later on. And the next limitation is resource intensiveness. So running and maintaining open source models can be resource intensive, particularly for large scale applications if you don't have the necessary system requirements to host it. So these were some of the advantages and limitations associated with this model. While open source models offer numerous advantages, including cost effectiveness, community support, and flexibility, they also come with challenges such as complexity and limited support. Weighing these pros and cons is crucial when deciding to use open source models for your projects. And with this, we come to the end of this video. I would like to thank you for watching this demo. If you are interested in implementing this solution or need assistance with similar projects, please feel free to reach out to us. Our team of experts is here to help you bring your AI and machine learning ideas to life. To get in touch with us, you can reach out to us via our email ID, which is contact@codersarts.com, or you can visit our website, which is www.codersarts.com. You can also find our LinkedIn, Instagram, and Facebook handles in the description box down below. Also, please don't forget to like, share, and subscribe to our channel for more such exciting content. Thank you.